Hi, everyone. Hope you're doing well today. And today we're going to start the first of 6 gas laws that you need to know for chemistry. So, the first gas law we're going to talk about is something called Boyle's Law. And Boyle's Law relates how pressure affects volume and how volume affects temperature. Now, I think the easiest way to think of this in real life is if you had a balloon and you blew it up and you tied off the knot. And then if you squeezed it, try to squeeze it down into a smaller volume, what would happen to the pressure inside that balloon? Well, as you decrease the pressure, to decrease the volume, the pressure goes way up. And eventually, if you squeeze that balloon hard enough, you're going to pop that balloon. So that's kind of what Boyle's law explains. So I'm going to start sharing my screen with you so you can see some examples of Boyle's law in action. So in this first one, we've got the formula for Boyle's law. And Boyle's law simply says the first pressure times the first volume has to equal the second pressure times the second volume. So let's say you have a container, and initially the container has a pressure of 1 atmosphere. That's just normal atmospheric pressure. And the volume of the gas, let's keep the numbers easy. Let's say the gas takes up 8.0 liters initially. Okay. Now, let's say you can compact or squeeze that container. And let's say I'm going to squeeze that container really hard and I'm going to get it down to half the size it started out with. So my second volume is going to be 4 liters of gas. So I'm taking the same amount of gas, the same number of moles of gas, and I'm compacting it down into half its size. How is that going to affect its pressure? So what I'm asking you to find in this problem is what is P2? So let's start by doing a little bit of algebra. So let's recopy this equation. P1V1 equals P2V2. Okay. And what we're trying to find here is P2. So we want to get P2 alone on one side of the equation. And the easiest way to do that is to divide, remember your algebra, both sides by V2. So if I divide both sides of this equation by V2, V2 is going to cancel out on the right. And what I'm going to have left is that P1 times V1 divided by V2 is going to equal P2. Now, when doing these gas law problems, generally I think it's easier if you do the algebraic steps, if you do the algebra first, and wait until you get it set up to plug the numbers in that are in the problem, okay? So let's plug some numbers in. So P1, our initial pressure was 1 atm, so I have 1 atmosphere pressure, times V1, which was 8.0 liters, and we're going to divide that by V2, which is 4.0 liters. Okay, and that's going to give us our P2. Okay, so before you do your calculation, as always, just like with stoichiometry problems, it's a good idea to go through and check your units and see if they cancel out. So liters are going to cancel with liters. You're left with atmospheres, which is a perfectly great unit to use for pressure. So I have 1 atm times 8 divided by 4. Plug this into your calculator. 1 times 8 divided by 4 is simply 2 atmospheres. So our new pressure, P2, is going to be 2 atms, 2 atmospheres. Now, think about that for a second. And if you think about it, it kind of makes sense. Because what did you do to the volume? You cut the volume in half. And Boyle's law says that if you cut the volume in half, the pressure has to go up. And what did we do to the pressure? Well, we doubled the pressure. Okay, so what we call this, another way to say Boyle's law, is that pressure and volume are inversely proportional. inversely proportional. What does that mean? That means if pressure goes up, the volume has to go down. Or conversely, if the volume goes up, the pressure has to go down. All right. Hope that makes sense, you guys. Uh, have a great day.